Well, I'm going to change the pace a little. First, believe it or not, I joined here in 1971, which was 2 years before the department started. So as a consequence, you can classify me to be a dinosaur. But unlike dinosaurs, I've been trying to adapt, learn, and my primary teachers have been all the students who I've worked with. And believe you me, you guys have taught me a lot. If you go to the departmental webpage, my area is listed as systems. But being around for that long a time, I guess I can philosophize a little. So let's do some of that. What is a system? We have been building systems for a very long time. And it typically consists of what? Processing elements, storage elements, communication links, and lately a lot more sensors and actuators. And as the sizes and the power requirements and such things go down, the sizes keep going down, powers keep going up, we build more and more and more complex systems. What is a complex system? The one that has a lot more things interconnected. But I would submit to you that any and every system that we build is ultimately used by a human being. So let's see what the implications of that are. Let's go to some basics. There is a clear distinction, I'll submit to you, between information and its representation, to the point that any and every thing that we call information that we manipulate in physical world is a representation. So if I say 2, how many different representations can I have of that? Lots and lots of them. But in your head, 2 means 2. Okay? So there is that distinction that comes about. I would also submit to you that every representation that we create is by an arrangement of energy or matter. And we have all kinds of means to manipulate what? The representations, not the information itself. Because the only place where you can manipulate information is in here. So we have designed all kinds of manipulations, but only you and I can work with that. Another thing that comes up is that every piece of information has lots and lots and lots of interrelationships. Call it its context. So if I was to talk about a car, how many different kinds, pieces, types of information are related to it? Here's just a partial list. And you can keep on expanding. So for me to be able to talk about any kind of information, I do need to talk about its context. And then for each of these kinds of information, I can build a model which reflects all the context. So what happens? I start out with some information. I want to create a representation. How do I create it? From information to representation, whatever is in my head, I create using that, and that's a sentient being. Now, if I want to send it over, what I transfer is the representation, not the information. And on the other side, a reverse translation takes place. So if I'm trying to send an idea to you, what assurance do I have that you got the idea that I was trying to send? Because I already translated it from that idea to the language, and then to the sound, and then you heard that sound. Maybe you were dreaming, didn't even hear that sound. Idea never got anywhere. Anyway, there are lots of implications of that. Let's take a look at one. Suppose I wanted to carry out an operation, manipulation of a representation. So I had these bits, 0, 1, another place, 1, 1, passed them through some circuit, out came some other bits that I was representing, and I say I've added. How have I added? All I did was to pass some of these electrical circuits. I've added because at this sentient level, it makes sense. That's how I have added. There are lots of implications of this in terms of these information manipulations, but I would submit to you that only those manipulations that make sense at the information level are meaningful. And I can use them for triggering actions and other kinds of things. Similarly, if I was trying to communicate I can send information. But another interesting part that comes up is that both sides in communication maintain a model of the other side. What is a protocol? Nothing but a model. That when I send you this, you send me back that. I would submit that any and everything that you and I are dealing, we are carrying lots and lots of models. Why don't we have them in the computer implementations? Because we didn't have enough resources. Anyway, moving right along. Interrelationships become important. So who is an expert in the field? Who understands more and more and more of the interrelationships. So if we take a look at a complex system today, there are all kinds of components that are in there. They're connected in all kinds of ways. And anytime we have any interrelationships that are well understood, I have a mathematical model, I have algorithmic representation. I attended Dr. Ming Lin's class and know how to model physics of it. That I can then create a software representation and do that. When I don't, then what do? Human operators come in. So this is the NASA control room. How many human operators are there? They are taking into account all kinds of things that the machine can't. So what's happening? I have a complex system and there is a human operator who is taking into account additional inputs compared to what's available from just the complex system. How does the human operator take that into account? By knowing the interrelationships that exist. If I can codify that, I can create a software model. And the more I can codify, the simpler I can make the complex room. Anyway, on this notion of separation between information and representation, typically I spend a semester in a graduate level class. But today I won't give you the full class in 6 minutes. So let me give you a sales pitch about the kinds of things that we have been building. We have been building lots of context-aware systems. So, by the way, I was hired here to be a problem solver. And so I've been a problem solver in whatever domain that problem arises. Lately, one of the kind of things we have been focusing on is in context-aware systems. Another area where we have been focusing, in time permitting, I'll give you some details of that. Otherwise, there is a poster that you can take a look at, which is about understanding human physical and mental conditions from sensors. And we are collaborating with the School of Public Health as well as some companies to do the breathing analysis, to know your locations and monitor how flu virus spreads on campus, how the mental activities get affected when you're hearing a particular type of sound, etc. But let me first walk you through the context-aware system. First one that we built, this is the third version of that, is to bring the relevant context into account. As I mentioned earlier, context can be a heck of a lot of things. So here is an example of a road accident. And clearly we have a model of a person, a template. But relevant to this accident, we only require medical records and maybe some personnel and what automobile they might own. So here is a situation graph, initial template. And as additional information comes in, we populate that. If some actions are required, those are guided. But all this is a support system for a human operator. Another one, structant. This, in addition to taking the relevant information into account, also reflects policies. And the originating example of this was when one of the companies was flying drones over a 10 mile by 10 mile, 100 square mile area, collecting about 10 terabytes of data in terms of pictures, and wanted to reconstruct a 3D rendition of that. They wanted it done in 4 hours. A company that was trying to do after 15 days gave up. Why? So much data, how to move, where to process, and all that. That was the original example of this. And here we have computational operations with dependencies, and they have to perform a series of data set manipulations on how to manage that. The key idea is here is the computation resources. You have a controller. There are some structured representations on each of those locations, and the controller is providing the actual guidance. Another one. How many here have heard of software-defined networks? The rest are asleep. Borrowing the ideas of software-defined networks, we're trying to build software-defined software. Again, what is the key idea? The controller, here's a mail center, pull the controller part out, and then here's a mail center example. We in the group also have quite a bit of computing power with a large cluster and other things. Here is what you'd see on the poster. Thank you. Part of the thing is from the first slide, you know how to spell my name. Second challenge you have is how to find me. I'm still in this building, and my standard statement is I'm always in my office except when I'm not. Talk to you.